It's that time again. This time for loops. Loopity-doops. Looptastics. And it's not a hyperloop because it's actual science. Oh, that's a shot across the bow. All right. Wow. Hold on. I am restarting here. Okay, I'm good. All right. Primes. We like numbers, right, guys? Well, that is not, 6 is not a prime for some reason. All right. So, this is a classic example. Okay. We know what this does. Let's do it. There you go. All right. So, we already know what this does for n. It goes through a given sequence. So any kind of whether that's a list or other type of data type that allows sequencing, you can go through it with the for x. See, we can change this to x because that's just a name. So we're saying for whatever we want to call it in whatever we're pulling from. Very simple. But let's go ahead and look at something a little bit more complicated. So we can still use the same structure for x in. But let's go ahead and add some other data. Let's say a range. We used kind of a weird range earlier, but this is actually just the range function. And what we're going to do is we're going to return, let's just do 10. All right. And then we're going to say print x. Okay, let's go ahead and run it. We go 0 through 9 because our range is 10. Okay, so our range is 0 to the range that we're getting at, or the range that we've defined. So we stop at the range that we define. So if we wanted to do exactly 10, or if we wanted to get to the 10 value with the 0, we do that. Or if we want exactly 10, we can do +1. There you go, 1 to 10. There's just numbers and number indexes. To elaborate just a bit, programming languages and computer indexes always start at 0. So if there is a 10 length list, there are 0, 1, 2, 3 through to 9 boxes. So there's still 10 boxes. So the length of 10 is accurate, but there are 0 through 9. Commonly, you fix that by +1ing it. So in this case, what I did here to just change the display. Other times you can up the value if you include 0, but you actually have 11, but you see 10 indices. It's really just depends on what you're actually doing at that point, but just keep that in mind. It's very common. It's used all throughout computer sciences. It's really not anything special. So commonly used in other languages, the while loop. We can do count equals 0 while count is less than 10. Then we'll print the count. Let's go ahead and comment this one out. And then count plus. And then let's run it. Oh, wait. Count plus doesn't work. Yep. This is one of the things that it kind of just made me a little bit sad. You cannot use count plus. You cannot use a numeric value plus or minus. In Python, instead, you have to go a little bit longer with plus equals 1. It's a little bit more concise. Yes, it is more direct. You know exactly what you're doing, but I still have that love of plus and minus in my heart, and it does break it just a bit. So let's just go ahead and continue from that. As you can see, it still works great. There's a few other things. We can actually add an else to loops. This is kind of interesting. What I'll do here is I'll add an else here, and then I'll say print count last val was count. I think that should work. Well, that is the wrong one. Yep, there we go. All right. So as you can see, we're using else to break out of the loop and then do something at the end. It's very interesting. Most languages don't have this, and it's something that I kind of wish they did because it's really useful. And you can do some pretty fun and pretty straightforward logic without kind of mangling your syntax or mangling your logic and what you can read. And it's just powerful. It's really something that I think other languages should look at and kind of adopt. So yeah, we can, I showed you range up above. So let's go ahead and do 4x in range. We can do targeted ranges, so 1 to 10. And we can print x. And then let's go ahead and just comment this out for simplicity's sake. And as you can see, we have 1 through 9. Again, this is the thing I'm talking about where the last value is declusive. So we are not including the last value. So if you wanted to do 1 through 10 exactly, you'd have to do 1 through 11. But that makes pretty reasonable sense, all things told. There is usual operators. We can go through here and say if x equals 3, break. I don't know why I put a semicolon there. And we can then call that, and you'll see it'll stop it. That break ends a loop. You know, there's the usual type of stuff that you can do with this. You can also do, let's say we just don't like 3. Let's next. Wait, it's not next. It's continue. But what we can do is we can say this. Put our print afterwards, right? So there you go. It's just some more interesting logic that we can do with loops. We're going to be looping through data in the future pretty quick here when we start doing some fun stuff with Python. Loops are pretty much going to be the end-all be-all of data sorting and whatnot. But do not become too reliant on them. Try and work your way through problems with as few as possible, because especially if you have nested loops, as soon as your data sets get into the millions, you're gonna cry. But there you go. I hope you learned something, and do please join me for the next video, which will be coming up very soon. And thank you, and goodbye.